Welcome back to The Explainer. Today, we're tackling a massive, often completely overlooked hidden cost in industrial design. We are going to build a definitive procurement comparison guide entirely based on CINMAS engineering guidelines. And the subject? Cable trays.
2 to 3 times. Yeah, you heard that right. That is the massive cost multiplier you're dealing with when you specify a stainless steel cable tray compared to a standard galvanized one at the exact same load class. I mean, that is a huge, sudden jump in your capital expenditure.
Okay, let's dive into this. The core philosophy we're examining today is actually pretty simple. The difference isn't about just being cautious, it's about whether corrosion will stay cosmetic or if it's going to start affecting load capacity. Buying stainless just to be safe without a real engineering justification, well, it's often a massive waste of capex.
So, here's our game plan for today. First, cost difference and over-design. Second, corrosion, cosmetic versus structural. Third, life cycle and material comparison. Fourth, conditions requiring stainless. And fifth, checklist to avoid over-specification.
All right, kicking things off with Section 1, cost difference and over-design.
Look, that 2 to 3 times premium? It's absolutely justified in some environments, for sure. But in others, it's literally just pure waste. Defaulting to expensive stainless steel out of blind caution doesn't magically make your facility better. It actively hurts your bottom line. We really need to replace this fear-based purchasing with solid, evidence-based engineering.
Moving right along to Section 2, corrosion, cosmetic versus structural.
And this brilliantly illustrates the real issue. Cosmetic corrosion might not win any beauty contests, but you know what? It's fundamentally safe. It's merely an aesthetic issue. Structural corrosion, however, that is the real enemy. It degrades load capacity, it completely breaches hygiene compliance, and it dramatically increases your outage risk. True engineering prevents structural failure, not just surface marks. Bottom line, if you're paying 3 times the price just to prevent cosmetic corrosion, you are severely overpaying.
Next up, Section 3, life cycle and material comparison. Now, what's really interesting about this matrix is that we aren't just choosing between galvanized and stainless like it's a simple coin flip. We have a whole spectrum: pre-galvanized, hot-dip galvanized, 304 stainless, and 316 or 316L stainless. The engineering framework dictates that buyers must make their selection, especially when deciding between 304 and 316L, based strictly on the actual corrosion mechanism present in their specific environment, not just the price gap. You literally have to map your life cycle cost directly to the environmental reality.
Which brings us to Section 4, conditions requiring stainless.
According to the framework, there are 6 specific field conditions where stainless steel transitions from a nice-to-have luxury to an absolute structural necessity. We're talking about environments with heavy chemical exposure, high salinity like coastal areas, strict cleanroom hygiene requirements, direct food processing zones, highly humid underground tunnels, and high-sulfur industrial plants. In these instances, if you don't use stainless, structural corrosion will take hold. That makes the cost multiplier a vital, non-negotiable investment to prevent catastrophic outages.
Let's move to our final piece and see how this builds into our ultimate procurement comparison guide. Section 5, checklist to avoid over-specification. So, the crucial point is knowing exactly when to say no. Your ultimate tool here is the do-not-overbuy checklist. The framework explicitly lists 9 specific field conditions where specifying stainless steel is a complete over-specification. Ready? Here are the 9 conditions. Standard climate-controlled server rooms, typical commercial office buildings, dry underground facilities, areas with only cosmetic dust, non-corrosive manufacturing floors, standard warehouse environments, general retail spaces, indoor substations with moisture control, and residential high-rise service shafts. If your site falls into any of these 9 conditions, upgrading to stainless just sets your engineering budget on fire without doing a single thing to actually improve the reliability of your cable tray system.
Now, you might be wondering who put this together. This rigorous, data-driven framework comes directly from Xinma, Shanghai Xinma Busway and Cable Tray. They're a manufacturer providing proven, intelligent systems for data centers, rail transit, industrial plants, and commercial buildings. Their engineering solutions comply with top-tier global standards. We're talking IEC 16537, NEMA VE1, BSEN 50085, and GB 31251. So this isn't guesswork. It is certified real-world engineering logic.
Which leaves us with this final thought to ponder. Is your next cable tray specification built on actual engineering, or is it just really expensive caution?
The next time you're staring down a procurement sheet, I want you to remember those 9 conditions to avoid overspecification. Stop paying for aesthetic peace of mind and start focusing entirely on true engineering return on investment. Thanks so much for joining me on this explainer. I hope it helps you make sharper, way more cost-effective decisions on your next project. Catch you next time.